Right, so in this video, we're going to look at simultaneous equations or systems of equations, so depending what you call it. And part one is going to be doing this by graphing. Okay, so the first thing we're going to look at is, what is this topic about? Okay, so let's think about these two equations. We have y equals 2x plus 1, y equals 3x subtract 4. Okay, so these two equations, they're linear equations, and we've looked at these in past videos. I could graph them, and we can get all kinds of solutions. The first thing we know about these two is that they would have an infinite number of solutions. If I graph them both separately on two different graphs, the graphs could go on forever and they would have an infinite number of solutions. Okay, so if we put this in a Venn diagram to help me explain this topic, okay, we would have some numbers that would work for y equals 2x plus 1, and we would have different numbers that would work for y equals 3x minus 4. They are both different equations. However, is it possible that they have ordered pairs that would go in that middle section that would satisfy both equations? And that's what this topic is about. Is it possible, and can we actually find that solution? So we're going to look at first doing this using a graph, and then we're going to have more videos where it does it algebraically. Okay, so let's take these two equations then, and we're going to now put them on a graph. Okay, so we have y equals 2x plus 1, y equals 3x subtract 4. If you're unsure of how to graph, you can go back and look at my previous videos. Just a little quick recap, you could do it by a table, x and y intercept, or you can do the rise over the run, which is the one I like the most. So when we do rise over run, we take the gradient or the slope, and we write it in terms of rise over run. So in this case, it's 2 over 1. And then because it's positive, I always say go to the right. If it's negative, you run to the left. So we're going to take our y-intercept, which is 1, which is going to be here. Be careful of your scale. So in this question, my scale goes up. Each square is actually 2, but on the bottom, each square is actually 1. So it's something to be aware of. So I'm going to rise by 2, so 1 and 2. And then I'm going to run by 1, but because my scale is 1, that's where it would be. However, we need to start from my y-intercept. So here's my y-intercept. I'm going to rise by 2, 1, 2, and I'm going to run by 1. Rise by 2, run by 1. And that is how you would get the equation of y equals 2x plus 1. Okay, you can do the same with the other graph. You can pause this and have a go, but I'm going to show you what this is. So you start from -4 and you would do rise over run, and you would have this equation. Now you look at both of them, we notice that they actually intersect each other. They actually cross over. And this is important for when we're trying to find a solution that works for both. The point of intersection, which in this case is going to be 5 and 11, that is the solution that works for both of them. So it doesn't just work for one, it works for both of them. So when we have linear equations, if the gradient is different, they will have exactly one solution when you graph it. And we can check this. So if I substitute my x and my y value into both of these, it will work. So y equals 2x plus 1. Well, 11 equals 2 times by 5 plus 1. Well, 11 equals, and that would be 11. So that would work. And then if we try the second equation, we have 11 equals 3 times by 5 minus 4. Well, 11 equals 11. And that's how we know it works. So two linear equations, if their gradient is different, they will intersect at exactly one point. Which brings me now to the next part in this video, is what we need to be aware of. We need to be aware of different types of graphs. Okay, so the first one we have just looked at, it's when we have two linear equations and their gradient or their slope, depends what you call it, is different. They will intersect at exactly one point. They have exactly one solution. So in this first graph, their one solution is when x is 1 and y is 3. That works for both. The second graph, if you look, you should be able to see them and say, okay, right, their distance looks the same throughout this graph. If we actually look at the equations, you will notice that their gradient is the same, which means that the distance between them is the same throughout the whole graph. It means that they are parallel. If two lines are parallel, they do not ever intersect, which means these two equations have no solution. There's no ordered pairs that would be on both lines. The last graph that we need to be aware of is it just looks like we have one line. However, we have been given two different equations, but whether we rearrange them or we graph them, we notice it gives us exactly the same line, which means every ordered pair works for both lines. And we say this is an infinite number of solutions. Okay, so we have exactly one solution when their gradients are different. Two linear equations intersect at one point. It has exactly one solution. No solutions is if we have parallel lines. An infinite number of solutions is when you have two linear equations that graph exactly the same. Right, the last thing we're going to do then in this video is look at a real life question and see if we can solve the real life question using a graph. So, we have Lee went to a concert with his family. He purchased 2 adults and 2 child tickets for $26. Danielle went to the same concert with her family. She purchased 3 adult tickets and 1 child ticket at $31. Using a graph, can we find the price of 1 adult and 1 child ticket? So, the first thing I'm going to do then is say, I'm going to write an equation for both of these situations. They both have talking about the same thing, so they're talking about adults and children, and they're going to the same concert. So I'm going to call adults X, and I'm going to call children Y. So if you're going to write an equation, I know 2 times the adult price plus 2 times the child price is going to equal $26 for Lee. And for Danielle, if she has 3 adults and 1 child, so just an X, a Y, sorry, it's going to equal $31. So first, we need to start off with our equations. So we have 2x plus 2y is 26. X stands for the adults. And then we have 3x plus y is 31. Y stands for the child. So now if we use what we've been doing in the graphs, if I graph both of these on the same axis, wherever they intersect is going to be my answer for this. So wherever my X value is will be the adult price. Whatever my child's value is will be, the Y value will be the child's price. Okay, so again, if you need to recap how to graph, there's plenty of videos. For these types of questions, I would probably use the method of the X and the Y intercept. So if you do X is 0 and substitute that in, we have 2 times 0 plus 2y equals 26. You're left with just 2y equals 26. Divide both sides by 2, y equals 13. So when x is 0, y is 13. So that's the first ordered pair I could plot. So when x is 0, y is 13, which will be here. And then I would do the same with the y, the x-intercept. So 2 times by x plus 2 times 0 is 26. Because they're very similar, in this case, we're going to have x equals 13. So when x is 13, y is 0. So if you need to go over that method, there is plenty of videos if you go back on my channel. And that's a different way how you can graph when it's in standard form. So if I graph Lee's situation first, now I'm going to graph Danielle's situation. You will see that they intersect at exactly one point. And if we read that point off the graph, we have x is 9 and y is 4. So that means the adult tickets are $9 and the child tickets are $4. And that's how we can use a graph to solve a real life situation.